Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.
Over the last decade, we've seen flat earthers come and go. Some slipped away quietly, while others flamed out in spectacular fashion. Jeranism recently tapped out after finally seeing the 24-hour sun in Antarctica. Others that continue on after TFE have to explain that observation with mental gymnastics that will put Simone Biles to shame. In that time, we've seen flat earthers scramble to create proofs for their model, most of which just highlight how poorly they understand the globe model. But once in a while, a couple of them emerge who can actually push buttons on a calculator without poking themselves in the eye. Enter Alan and Shane St. Pierre, the self-proclaimed pioneers of Aether Cosmology. You might remember Shane from a halfway civil conversation we had a few years back while he was still riding the fence. You'll also know Shane from his plagiarizing of Walter Bislin's Flat Earth model and calling it his own, all while ignoring this quote-unquote model has to bend light in a physically impossible manner as mentioned by Walter Bislin himself. But now, he's cannonballed into full flirf mode and teamed up with Alan, who tries his best to sound cool while speaking in slang that expired with MySpace. Their new revelation? Something called the Celestial Theodolite, a tangled method involving timing a star as it disappears behind a mountain, performing some trig, and then comparing that angle to what Stellarium predicts. Let's pause there for a second. Stellarium. You know, the planetarium software built on heliocentrism, spherical coordinates, Earth's axial tilt, orbital motion? The one that accurately simulates the night sky from any point on Earth? On a globe? Yeah, that's Stellarium. They use that to prove flat Earth. The irony, of course, is that not even other flat earthers seem to understand what they're doing, which is probably why they've revised this method 15 times and counting. Every time Ruhef or Jesse Path of Light expose a flaw, they Frankenstein a new version into existence. So I decided to ask them a few questions. Not about the math. I made that clear that I wasn't there to dispute their trigonometry. Instead, I asked something far more basic.
No, don't disagree with the math, but I have a different question.
Sorry, can you repeat that?
I said I don't disagree with the math, but I have a different question.
Oh, go ahead.
So if we're using Stellarium, if Stellarium gives us accurate position of stars with respect to time, where does Stellarium say the star will be 6 hours after it's been occluded by the mountain?
Alan and Shane immediately defaulted to evasive rambling about negative coordinates, negative z values, and fundamental planes, claiming the star simply moves away from you.
Well, relative to that observer, probably some negative coordinate.
Yep. So in spherical coordinates, right, when you have a fundamental plane, because you're only making a hemispherical observation, then it would be represented with the negative z value, which is just meaning below the fundamental plane. It's the predictive capability is simply based on the circumference value and whether that circumference is the star traveling out and away from you to rise and set on flat Earth, or theoretically beneath your feet in the celestial sphere model, the circumference is the same, makes no difference.
Alan insisted it continues on its path, but somehow isn't actually below you, even though Stellarium shows it in its exact position.
So does the star continue on its same path that it's traveling down towards the mountain? Does it continue on its same path after it's been occluded?
Presumably, yeah. There's no reason to assume it doesn't.
The conversation spiraled as they tried to juggle contradictions.
So then 6 hours after it's been occluded, Stellarium says it's going to be below my feet.
Yeah, did you not hear what he said? So Shane just gave you an explanation about negative coordinates and it being based off of the circumference and whether or not it's arcing above you with your dome of vision and setting in your due to optical reasons, or if it's setting due to physical curvature and you're rotating away from it because you're on a ball. The math to describe the two functions would be the same.
I asked, what direction does the star go? Does it move left, right, underneath? Their response, it's just math, bro. Same function.
So physically though, where is a star physically?
Always above us, according to the measurements here.
coplanar with the ground. It turns out everywhere you look, wherever, and only just because your model conceptualize it with a sphere of infinite radius as a model derived from zenith and ground conditions doesn't really mean anything, dude. It's not really a good argument.
They repeated negative coordinates like it was a physical direction.
Please stop making
Correct.
that.
Okay, so you guys claim that since you just said it continues on its same path, right? Which is down, but it's not. Where is it physically? If it's not actually below me, which direction does it go once it's occluded? If it's not actually below
that
me,
you're referencing is optical, right? It's setting into the horizon, so it looks like it's going down. That's an optical effect.
So, a better question.
How does it end up behind me in the morning?
Well, like Shane was saying, mathematically representing it with negative coordinates, whether it's circling above you and it's setting due to optics, or if it's setting due to going around a ball and then rotating around on the other end, the mathematical function to describe that would be the same. It tells us nothing unique using the apparent position of the star.
As if labeling it with a minus sign made the geometry vanish. I told them straight, negative coordinates don't tell me where the star actually is.
Do you guys like honestly, do you really believe that a star is not below you once it goes below the horizon in Stellarium?
You know, this is the same argument as the sun can't set, right? Like, we believe it goes away and you takes its light with it and becomes you can't see it, right? And you say, well, no, it's beneath your feet. Let's just deal with the math right here, because people have said that there's a fudge factor, and that's the only way this works. If anybody could point out to me on this slide where the fudge factor is, I would be greatly appreciative.
So this is the problem I'm having with this method you guys have derived, right? It's pretty convoluted. I mean, I guess if you understand the mathematics, okay, it might work in certain circumstances. But my question is, if we're using Stellarium, for the position of stars, Stellarium tells me that the star 6 hours after it's occluded is below my feet. But apparently, you guys, for some reason, either it's not going in that actual direction, even though it's continuing on its same path. That just doesn't make any sense. And that'll be the end of it.
Real quick before we continue, though, can you repeat back the explanations that was given to you? Like, do you know what we said as like how it would function?
Yeah, you guys say negative coordinates, but that doesn't tell me physically where the star is.
No, it tells you exactly where it is because it's negative coordinates based off of time.
But where is that actually? If it's not actually below me, where is it?
It's just above you, further away.
So which direction does it go after it? But which direction does it go after it's occluded? Does it go to the right?
All right, well, before it gets to the horizon to do the thing you're doing, it passes by the mountain peak at precisely a time that says the Earth is flat. Do you agree with that premise before it gets to the bottom?
I mean, I'm not really concerned with that. I mean, you can fudge that either way you want using, but I'm concerned. You guys are like ignoring this huge thing, right? You're ignoring the fact that if you're using Stellarium and you guys are saying that Stellarium is accurate, then after the star goes below the horizon, it's continuing on its same path.
Listen,
and then it rises the next day behind me.
One of their own, Jason, pretty much nailed it with this comment.
There's got to be a reason why why you can visually see it below you as an apparent position. Is that reason because of curved visual space? Is that reason because of refraction? Or is that reason why can we see it below our horizontal? In geometry, if something is below your horizontal, that means it is below your horizontal.
You don't. The calculation comes out that way because you're not accounting for a dip correction because you're not on the surface of the Earth. So it's not a real negative angle.
Yeah, the observer height is not at the surface of the Earth. So anything below, you have to be on the surface to the inch to get that below that. So any observer on the surface obviously isn't at the same angle. Therefore, any angle subtending that would not be below anything. So it's an arbitrary question. But
it's a fair question. But if we applied a dip correction, do you understand that the angle would just be positive and it would be fine? Like there's no issue.
Yeah, but what is the dip correction for? Dip correction is just for observer height?
Yes.
But that still means the star would be going below the horizontal of the observer. Why there has to be a reason why a star goes under the horizontal of the observer. If that's refraction or if that's curved visual space, it should not go below the visual horizon of an observer, the level horizontal.
Then another person chimed in and called him out directly.
I mean, they asked if anybody wanted to address the math and nobody did. So to try to force a room to talk about math that can't even be verified is kind of lame, that there are people trying to talk about this and you're like, let's not talk about it. We're not going to talk about it. We're just going to talk about math. I don't know. It just seems kind of...
And that's exactly it. The moment they're faced with the physical consequences of their method, the implications of where the star goes, they shut it down. Alan literally said, "Do you want to move to another question?" Because they knew they were backed into a corner. Geo, trying to jump in and white knight for them, tried pulling the azimuthal grid card, claiming Stellarium has a setting where the stars don't go below the ground. Cool story. But the angles and timing they use for their method, those come from the equatorial grid, which doesn't really matter anyway because both settings show the stars going beneath you.
I was just going to say it's a non sequitur to what this is, though. It's just a different topic. And on Stellarium, there's two settings. Right at the bottom, you see all the icons. There's an equatorial grid, which essentially treats the Earth as a sphere and puts the celestial sphere all the way around that sphere Earth, which is why you can turn off the ground layer and you can see the stars underneath you. Or right next to that, there's the azimuthal grid. If you turn on the azimuthal grid, it treats the ground as a planar circle, and the stars do not go underneath the ground. So Stellarium has two settings. One of them is the azimuthal, which is essentially a geocentric planar Earth foundation. The other one is the equatorial. So, Bebal, when you're saying that, that's not true. Only the equatorial only the equatorial grid treats the stars as going beneath your feet, and it's a completely separate issue than what this is.
A very good point.
The stars always go below your feet in Stellarium.
No, they do not. If you turn on the azimuthal, that is incorrect. If you turn on the azimuthal grid, they do not go under your feet in Stellarium.
So where do they go?
Hold on, they're out of your vision. They're just further away from you. D3 already explained that. The equivalence between the two, it's identical. It would be mathematically represented by the same thing. There's no difference.
Which direction do they go?
East to
west.
west.
Once they're out of my view.
They circle around you. You see them arc across your field of vision.
Okay, so let's go to the equator. What if a star goes straight down to the horizon?
Same thing, dog.
Where is it still going in that straight line? How does it come up behind me?
Bro, 1 second before. Okay, so it's just math to the same function. There's literally no difference anywhere. Equator, North Pole, 33rd latitude, 38. That doesn't matter. All the same answer every time.
So this again at the equator, stars going in a straight line.
All right,
I can't
continue with that anymore.
So let's break this down. Their method is built entirely on a globe-based coordinate system. They use globe-based software to validate their angles, but that software shows a result that supports the globe. The fact of the matter is, you can't use Stellarium to track the motion of stars, then pretend its predictions are meaningless the moment they contradict your belief. That's like using Google Earth to prove that continents don't exist. So props to the brothers from Aether Cosmology for creating the most needlessly complicated way of accidentally validating the globe. You've given us the only method in history that needs 15 revisions to tell us that the stars are where Stellarium and the globe said they'd be all along. Once again, thanks for watching. Don't forget to like, share, and subscribe if you like this video. And please, check out the rest of my videos if you're interested. And as always, peace.
Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.